Good afternoon, everybody. It's Dave Blanchette. I'm the engineering manager for the ICM group, and I guess it's good morning to some people on the West Coast. We're going to talk about the Pulsar pH control system today. This is a system that we designed specifically for use with the slow dissolve feeders, and it also can be used on some of the larger units as well. So if we look at the overall basic details of the Pulsar pH control system, again, it was designed for intended use with the infinity feeder. It is used to maintain the proper pH levels in pools that typically do not use ORP control, although it is perfectly suitable for use with ORP controllers as well. The unit itself is comprised of a tank, which is a very rugged polyethylene tank. It's a linear low-density polyethylene, so it has good resistance to temperature variations. It's extremely chemical resistant to acid, which is a good thing since that's what it's holding. And it also is designed to incorporate and hold an easily serviceable peristaltic dosing pump. It's easily adjusted to balance the pH, increases from the hypochlorite sanitizers. This hypochlorite that we use in the slow dissolve cal hypo feeders is somewhat unique in that we add lime to the cal hypo. So in addition to the alkalinity from the cal hypo itself, which is chlorinated lime, we have the added lime in the slow dissolve cal hypo tablets. So there is a fair amount of acid that is required to lower the pH and keep you in the proper range of 7.2 to 7.6. Specifications for the pH control system. It is designed to use 20 Bomb-A muriatic acid. This is the 32% by weight muriatic acid that is typically found in most of your big box stores. The Home Depots, the Lowe's, they carry this style of acid, and the dosing rates that we'll talk about a little bit later are directly correlated for this concentration of acid. The heavy-duty polyethylene tank and pump platform can be secured to the floor with built-in seismic restraints. If we look at a picture from the previous page, you can see down at the bottom right, you could see the little cutouts which have the holes which you can then use to secure the tank itself to the concrete or wood floor, either using concrete shields or the appropriate screws for wood. The tank is translucent, so you can see light does shine through, and that allows you to get a visual confirmation of what the actual acid level is inside. This tank is designed to handle the straight concentrated muriatic acid, so we do not recommend any dilution. Again, all our dosing levels are based on using straight muriatic acid, 32%. The pump is self-priming and is resistant to run dry, so if it runs dry, it's not going to damage the pump. You'll wear out your tube a little faster, but there will be no long-term damage to the pump itself. It has a valve-free pump head for easy maintenance. So we've selected this particular pump because it is very easy to change the tube out and the roller assembly. It requires no tools. It's very easy to do, and it's a fairly low output unit, and that is allows us to use this particular design, which is much easier to handle and to perform maintenance on than some of the other pumps used for acid feed control. Again, the unit can be used by itself. It does not require an ORP controller, but it can be used with one if one is installed on the pool. The primary goal of this system was to simulate automation without an ORP controller, and that is to match the acid delivery to the amount of chlorine that's being fed from our slow dissolve feeder, so that the acid in this will neutralize the lime from the Cal Hypo tablets, the slow dissolve tablets. We utilize the peristaltic dosing pump, as we talked about with the simple maintenance, to match the market needs. This is a feeder that is designed primarily for the HMAC market, which is the hotel, motel, apartment, condominium market, which tends to be less sophisticated than some of the other more sophisticated aquatic venues where you have professional aquatic personnel maintaining the pools. In many cases at the HMAC facility, the same gentleman that's taking care of the air conditioning is also taking care of the pool and the pool equipment. So we felt that this was a good match for the level of sophistication of the operator. Again, one of the things we tried to do when matching the acid delivery was to use very precise control of the output dial. And we'll get into that a little bit later with some of the other pictures that show the dial itself. The acid tank itself has a cap that has a nice gasket that forms a fairly tight fit. Not that it's pressurized, but it will prevent the release of gas from the tank. We know that muriatic acid wants to vent a little bit, and there is a little bit of venting on this, but we have made the securement of the polyethylene tubing where it penetrates into the tank. It's a fairly tight fit, so we limit the amount of gas that can escape into the pump room. For general purposes, just to understand how much acid it would need to be fed, 1 gallon of 20 Baume muriatic acid, or 32%, will neutralize the lime in 25 pounds of the slow dissolve Cal Hypo tablets. Just for point of reference, if you were looking at regular Cal Hypo, like our Pulsar briquettes, it would take about 1.5 gallons of this muriatic acid to neutralize 100 pounds of the standard Pulsar briquette. So there is a considerable additional acid requirement for the slow dissolve tablets, and that is because of the addition of the lime. So the pump's flow rate is adjusted by the use of the potentiometer on the side of the pump. If you look at the picture, you can see the pump there. It has the dial on the top of the unit. This happens to be the Stenner Econ LD model. It has the one dial, which it pretty much takes care of the speed that the motor runs, and that determines how often the tube is collapsed and how much acid is fed. We have different tubes that we'll talk about a little bit later. But for our application with a single unit, you would use a single, the lowest output tube for this particular pump. So if you look at that potentiometer, you can see that it goes from pretty much 0 up to 100. You can also see there's a gray area past the 100%. You do not want to operate the pump in that area. But to be the most precise, what we tried to do was use the largest portion of this scale that we could, so that the amount of acid fed could be fine-tuned to match the output of the slow dissolve Cal Hypo feeder. So you set the acid pump dial to the number that corresponds to the cartridge setting and inlet flow rate setting for your feeder, and we'll look at some charts that show us that correlation. Looking at these two charts, you can see that this is the acid output rate. And if you look at the chart on the top left, you can see this is specifically for one feeder. I want to draw attention to the pump dial setting where you see in white where it says the M tube, and that is the default. So that is the tube that is supplied with the unit. Actually, two of them are supplied. You get the one that comes in the pump, and then there's a second in the unit itself. So with this tube and this pump, it is set up for counteracting the alkaline introduced by the lime from one feeder. So let's just pick a point on this chart and discuss how we would set the acid feed based on the feeder setting for your Cal Hypo feeder. So if you had the cartridge set at A on your Cal Hypo feeder and your flow rate was 4.5 gallons per minute, you would set the Econ LD potentiometer to 36. So if we go back and we look at the potentiometer, you could see between 30 and 40, you have, it's probably something like a quarter of an inch to 3/8 of an inch. So you would set it just above, past half, between 30 and 40. So that's how you would choose the setting for a single unit set with your cartridge on A and your flow rate at 4.5. Conversely, if you were to have your setting at your cartridge on H and you had a 4.5 flow rate, you would set the potentiometer on the acid feed system at 82. So you can see there's a fairly wide range there, and we're using most of the scale with this single feeder in this particular tube. If you look next at the two feeder chart in front of us, you can see that this would require that you go up to the F tube. So if you have a multiple feeder installation, you're going to want to purchase the F tubes, which are sold separately, and we will show you the parts diagram a little bit later. I think it's one of the last slides in the presentation, and you will see what part number you have to order if you have a multiple feeder installation. So the reason we did this was so that if you were, in fact, to have a multiple feeder installation and you wouldn't be able to get enough acid with the single M tube, then what we would recommend is that you go to the F tube, and now you could see at a setting of H for the two feeders and a flow rate of, we'll use 3.5 gallons per minute, you can see that it would be, actually that's red, so let's use a setting of G, it would be 22. So you can see we're using a small portion of the potentiometer in this case, and that's because we had to use this F tube for both settings, for both the two feeders and the three feeders. But then if we look at the three feeder setup, if you have your cartridge setting on H, you would, at 4.5 gallons per minute for your output, you would have your potentiometer set at 83. So what we try to do is pick the settings on the acid pump that would give you the greatest amount of control and precision over the acid dosing. If there's any questions, you can ask them at any time. Simply use the chat feature.
Dave, where's the cartridge setting? Is that above it?
So the cartridge setting is on the feeder itself. So this is pulled from the slow dissolved cal hypo feeder. That's the cartridge on the feeder setting. Okay. And so the acid tank and the acid pump simply has the potentiometer. That's all you have to worry about. It's potentiometer. But you have to understand what your cartridge setting is on your feeder, your slow dissolved, your Pulsar Infinity feeder. That's where you're getting your cartridge setting from. If we look at the assembly and installation of the unit, it's pretty straightforward. The pump comes with two mounting screws, stainless steel screws. I'm not sure, I think they're 8/32, but I'm not positive of that. I'm quite certain that's what size they are. And you would want to use a Phillips, they're Phillips, so you would mount first get the pump mounted at the top using your top Phillips screw, and then you would take your second, it has to be a fairly long bladed Phillips screwdriver, and you would go place that between the pump inlet and outlet tubes on the right hand, you could see, of the pump, and place it in there, and then you would put your bottom screw in, tighten those both up, and that would mount your pump to your tank itself. The next thing you would want to do is you would want to cut your 23 inches of the 1/4-inch tubing that is supplied with the unit, and then you would place that and hook that up to the pump inlet, and then that would drop through the hole just above the filler neck of the acid feed tank that you see there. Once you drop that tubing through inside, then you'd use a hanger, or it's actually fairly close to that. So in many cases, you could just grab it with a screwdriver or your finger. You can pull that tubing out, and then you would want to install your foot strainer valve, which has a weighted feature to it. So that would take it to the bottom. Gravity would help take that to the bottom of the tank. and you would drop that down so that it is almost at the bottom of the tank to allow you to pump down to the bottom of the tank. The injection quill we use for this is very similar to the injection quills you would use in your standard acid feed systems. The one we get for this one is particular for the Stenner pump. We happen to use a FKM material for the duckbill in this unit, and that material is very good for handling the heat that is generated when acid and water come together. It's an exothermic reaction which generates some heat, and the FKM material is best suited to handle this increase in temperature and will give you the most durable lifespan for this. You can see that the unit itself, it can be used on larger pools. In fact, we talked about the standard M tube, and then we talked about the other tubes that we used in this. If we go back here, we talked about the F tube for the 2 and 3 feeder settings. But if we wanted to use this device on the largest Pulsar feeders that we sell, which could be a Pulsar 3, could be a 4, could be a 45, a 140, or a 500. Then we also have the H tubes available. These H tubes give you the maximum output rate for this particular feeder. And in this case, that can be up to 9.5 gallons per day, which you'd be emptying the tank daily, which I'm not sure is quite the right application for it. But it certainly can give you that kind of output rate. The pump is available in a higher voltage and a different frequency if we were to use this overseas where there are different electrical service situations. So the pump is available for that. This quick change tube, as I mentioned, can be accomplished without tools. Simply requires you to unsnap the cap that holds it on, and then you can the nuts that attach the tubing to the ferrule. Those are simply hand operated. You loosen those, pop your tubing off, and that will free up the tube to be removed from the system itself. If we look at the parts that come with the system or that are available separately, you can see that the entire system itself comes with the 2-pack of the M tubing, the lowest output. Again, if you have a 2 or a 3 feed system for the slow dissolve feeder, cal hypo feeder, then you would need to go to the larger tubing, the H tubing. The acid tank itself, linear low density polyethylene, is pretty self-explanatory. Again, it's the same color value as the Pulsar line of feeders, but we pulled some of the color out of it, so it's a lighter variation, which allows us to have better translucency so that you can see the actual level of the fluid inside the feeder, and you could look at it against the scale. The cap itself is a polypropylene injection molded. It has a compression washer, again, as I mentioned, and that will allow you to seal to prevent any vapors from escaping from the unit itself. They at least will be minimized. The acid pump is a Stenner Econ LD model, E10LHMA 1S36. We, for this feeder, only provide a laminated sheet with instructions on how to operate it. It has the output rate charts that we looked at. It has some basic other information on it, but for the most part, this feeder this acid feeder is a pump and a tank. So we include the actual Stenner pump manual for this, which is the Econ LD manual, and it has all the information that you will need to operate, service, and maintain that pump. Now, we do bring in our own spare parts directly from Stenner so that you can get the spare parts directly from us. We have our own part numbers. We don't use the Stenner part numbers, but if you were inclined or you had a direct line to Stenner, you could, this is a standard Econ LD pump, so certainly parts from them would work as well. If we look at the discharge tubing and suction tubing, it's straight 1/4-inch polyethylene. We provide a 20-foot roll, which is pretty much standard. It should allow you to get to whatever injection point you need to, which would be left over after you use the roughly 2 feet to go into the bottom of the tank. You see the 3 pump tubes listed there. We've got the M, which is the standard for the 1-feed system. That gives you up to 80% of the potentiometer range to use. And then we use the tube F, and that is for both the 2 and 3 feeder output systems. Again, with the 2, you'll only use about 25% of the potentiometer range. And then again, with 3, you'll go up to about 80% of the potentiometer range. Both of those work with a white roller assembly. So the standard roller assembly for the peristaltic pump is what you would use for those 2 tubes. If you were to step up to the H tube, as we mentioned, for the much larger pools, for the higher output where you're going to get up to maybe the ability to feed up to 9.5 gallons of acid a day, you would also need to change the roller. In addition to the tube going to the H tube, you'd have to go to the black roller assembly. And we do inventory the black roller assembly if you choose to use this system for some of the larger Pulsar feeders. You can see below, we've got the Econ roller assemblies. If you were simply replacing the white because it's worn out after a period of time for use with the M or the F tubes, that is available. The black roller assembly for use with the H tube most often would be used as the optional in the optional situation. Suction strainer, I don't know why you probably would lose this before you would have to replace it. There's very little stress on this part, and unless it gets lost, I don't know why you need to replace it, but we do have it available if you need to. The duckbill over time, an O-ring, that will wear out. Most cases, you can simply open up the injection check valve, pull out the duckbill and O-ring, and replace just those parts, since the plastic injection check valve itself should not wear out. You just have to replace the guts of it. The 8/32 by 3/4 round screws, stainless steel screws, if they get lost, we do have those available, but also it's probably a Home Depot item as well. We do include the pool calculator with the unit, and this is because we want to promote good balanced pool water. We know that one of the biggest advantages from the thousands of units that we put out to date is the impact that people are seeing on the water quality. It's been remarked on by many of our dealers, and we've been told from end users as well that they cannot believe the tremendous water quality, and that is the Cal Hypo advantage. As we all know on the line, that's one of the things we sell. And certainly we have to, in this case, in many cases, change the whole thought process of the people using trichlor in the past. They are taught to believe that high calcium is no good, that you need a lot of alkalinity in the water, and if you were running a trichlor pool, we know that's true. However, when they switch to Cal Hypo, and they switch to our slow dissolved Cal Hypo in particular, they're going to see higher pHs. They're going to see higher calcium hardnesses. So the acid feed system addresses the high pH issue by neutralizing the alkaline. But we have to, again, allow them to think a little bit differently so they understand that with this calculator, they can run high calcium hardness and run lower total alkalinities. And the reason we can do that is because Cal Hypo is mildly alkaline. It does not require a lot of total alkalinity to buffer the pH, because we're not pushing the pH real hard like you would with an acidic sanitizer like trichlor, or with a very basic sanitizer like liquid chlorine, where you would be pushing the pH real hard, so you would need more of a buffer in the water. So the calcium is higher, the alkalinity has to be lower, this is easily explained with a pool calculator in your hand to show them the pH of saturation as you change these two variables. You know, you're pretty much stuck with the temperature of the water and the total dissolved solids of the water, which are the other factors that influence the Langolier saturation index. So really you have three things that come into play, and that's pH, total alkalinity, and calcium hardness. We need to help these people understand that they'll be better off running the higher calcium and lower total alkalinity. That gives us better water quality, it gives us better feeder performance, and it gives us that sparkling advantage of the Cal Hypo pool. All right, well, thank you, everybody, for taking time out of your day to view this webinar. And if you do have any questions, as Krupa said, please let us know, and we'll get back to you. But again, thank you very much for your time, and a good day to all.